Thousands of asteroids orbit with us around the sun every day. From some as small as the size of your fist, to some others as big as cars. The threat of collision at the speed of thousands of meters per second is real. This is why NASA sent a spacecraft to one of the closest asteroids to Earth on a mission to collect samples and predict the chances of collision. The samples returned in late 2023, and scientists have been shocked at the results their analysis has produced. In fact, experts are saying that life on Earth might have come from these asteroids. What are in these asteroid samples? What results did NASA find from their analysis? And what are the chances of the asteroids colliding with Earth? Join us in this video as we look at how NASA just opened the largest asteroid sample. Our universe is a rapidly expanding and dynamic hub of activities. We live on a chunk of rock and metal, orbiting around a giant ball of grass and fire alongside other planets, in a galaxy that contains hundreds of millions of other solar systems like ours. This means there are billions of things going on every second that we do not know about and may never know about. According to scientists, since the Big Bang, the universe has been flinging itself outward for billions of years. And within this far-flung universe are certain celestial objects that serve as mementos, giving us a sneak peek into our universe, its operations and its future. We call these objects asteroids. Although they are often relegated to the genre of science fiction disaster films, asteroids have been shown to be immensely significant in our solar system. These leftover chunks of rock and metal from the formation of our solar system play an essential role in our understanding of the past, present, and even future of both our planet and its solar system. To understand this, imagine the solar system to be a massive construction site some 4 billion years ago. You would expect to see debris and flying pebbles everywhere, which is why everyone wears a helmet on these sites. Asteroids are the leftover debris, the cosmic rubble that never fully formed into planets. By studying what they are and what they contain, scientists can gain valuable insights into the early stages of our solar system. Many astronomers see asteroids as time capsules, preserving the chemical makeup of the primordial disk that birthed the planets. By analyzing their elements, scientists can come to understand the building blocks that formed our solar system, which in turn would provide a glimpse into the raw materials that went into creating Earth and its neighbors. Some of the asteroids eventually fall on Earth as meteorites. By studying these fallen rocks, scientists can peer back into time to understand Earth's early history. Some meteorites are believed to be remnants of protoplanets, celestial bodies that never quite formed into planets. By analyzing their composition, scientists can reconstruct the chaotic period of planetary formation and have a more rounded timeline of the events that led to the creation of Earth. There is also a theory that asteroids delivered the ingredients of life to Earth, and they may hold the key to unlocking the mystery of life's origins. Asteroids, particularly those rich in organic compounds like carbon and water, are believed to have collided with Earth in its early days. These impacts could have deposited essential elements needed for life to form, such as amino acids, the building blocks of proteins. While some asteroids hold the potential for life-giving molecules, others pose a genuine threat. Large asteroids on a collision course with Earth could trigger devastating global events, as evidenced by the Chicxulub crater believed to have wiped out the dinosaurs. To avert this, space agencies like NASA actively track near-Earth objects, NEOs, and develop strategies to deflect them if necessary. However, not all asteroids are bad news. Many contain valuable resources like precious metals, such as platinum and nickel, that exceed the reserves found on Earth. As space exploration matures, experts believe that asteroid mining could become a viable source of materials for future space endeavors and potentially even supplement our dwindling resources on Earth. This possibility is why NASA has birthed several missions to either deflect asteroids or retrieve samples from them in space. The most recent of these missions is OSIRIS-REx, which started in 2016. So what is OSIRIS-REx? OSIRIS-REx is an ambitious asteroid sampling mission. It was launched on September 8, 2016, for the near-Earth asteroid named Bennu. The goal was to retrieve samples from the surface of the asteroid and deliver the sample back to Earth. After this, it would then head off for an extended mission to study the asteroid Apophis. After arriving at Bennu on December 3, 2018, OSIRIS-REx took detailed measurements of Bennu's shape and mass before precisely slipping into orbit. It then collected samples from the asteroid's surface on December 31, 2018, and returned the sample to Earth on September 24, 2023. Of all the asteroids in space, why Bennu? Bennu is one of many thousands of near-Earth objects orbiting within 120 million miles of Earth. Among those, Bennu was one of less than 200 objects whose orbit was well known and sufficiently similar to Earth's orbit. According to scientists, This asteroid orbits the Sun every 436 days and comes very close to Earth every 6 years. Bennu is also relatively large enough for a spacecraft to land safely on it. It is about 1,650 feet wide. Also, Bennu has a more attractive composition. The asteroid is said to be rich in carbon-based material. This is an important detail. Asteroids that may have brought water and organic material to Earth and helped kick off life would have looked like Bennu. Bennu's close orbit also makes it a potentially hazardous object for Earth. However, NASA now estimates that the risk is relatively low. The probability of the asteroid colliding with Earth through 2300 is calculated at 1 in 1,750. And if it does collide with Earth, the impact will not destroy the planet, but it might cause some pretty significant damage wherever it touches down. Experts say that an asteroid of Bennu's size would likely devastate the local area around the impact, but it would not cause mass extinctions. Still, the advanced warning provided by the OSIRIS-REx mission could help scientists take measures long before an impact. One of such measures could be to redirect the asteroid entirely using the kinetic impactor technique as demonstrated by NASA's DART mission. The DART, Double Asteroid Redirection Test, mission was carried out on September 26, 2022, where a spacecraft was successfully crashed into a small asteroid called Dimorphos to change the asteroid's orbit. The mission was a massive success, with NASA officially announcing on October 11, 2022, that DART shortened Dimorphos' nearly 12-hour orbit by a whopping 32 minutes, smashing previous estimates. So what did OSIRIS-REx find on Bennu? NASA says that the sample collected was found to contain abundant water and carbon. This was, for many, very important news, because it serves as additional evidence for a theory that life on Earth came from outer space. This announcement came when NASA gave the public a first glimpse of what scientists found inside the OSIRIS-REx spacecraft's capsule. According to NASA Administrator Bill Nelson, this is the biggest carbon-rich asteroid sample ever returned to Earth. Carbon accounted for almost 5% of the sample's total weight, and it was present in both organic and mineral form. Bill Nelson also added that the water was locked inside the crystal structure of clay minerals. The findings were carried out through a preliminary analysis, which involves scanning the sample with electron microscopy, X-ray computed tomography, and more. Experts say that the preliminary results point to a likelihood of further discoveries that could support the theory that early Earth was seeded with the ingredients for life by celestial objects such as comets, asteroids, and meteorites that bombarded the young planet. In a statement, NASA said, "The secrets held within the rocks and dust from the asteroid will be studied for decades to come, offering insights into how our solar system was formed, how the precursor materials to life may have been seeded on Earth, and what precautions need to be taken to avoid asteroid collisions with our home planet." Another senior NASA scientist, Daniel Glavin, said that early analysis found the material seems to be loaded with organics. According to him, this stuff is an astrobiologist's dream. However, the analysis wasn't done on the sample contained within the original storage canister. In fact, no one at the announcement event got to see any of the samples firsthand, just photos and videos. The asteroid pieces are said to still be behind locked doors in a new lab at the Space Center, accessible only to scientists in protective gear. The images of the sample displayed showed a loose cluster of small charcoal-colored rocks, pebbles, and dust, found to have been left in the outer portion of the spacecraft's sample storage canister. Technicians were still carefully working on disassembling the canister containing the bulk of the specimen. According to Dante Loretta, principal mission investigator at the University of Arizona, the bonus sample of overflow material was immediately examined. She stated that scientists also discovered iron minerals in the form of iron sulfides and iron oxides, which themselves are indicative of formation in a water-rich environment. However, upon opening the canister, scientists revealed that Bennu contains a reservoir of a mineral called magnesium phosphate. According to the experts, these bright white particles are very rare to find in astromaterials. "It's no surprise that we initially thought this might be a contaminant," said Jessica Barnes, an assistant professor at the Lunar and Planetary Laboratory, LPL. Barnes is leading the phosphate analysis in the returned sample. Speaking at the Lunar and Planetary Science Conference, LPSC in Texas, Barnes said, "There are no good chemical analogs of the mineral on Earth, either because it is too fragile to survive the fall to Earth or vanishes soon after. Its presence in Bennu's sample can be used to infer different episodes of geologic activity on Bennu's parent body," she said. The samples also show the widespread presence of glycine, which is the simplest amino acid. This is, interestingly, a crucial ingredient of proteins, as well as other water-bearing minerals, including carbonates, sulfites, olivine, and magnetite. This suggests that Bennu's parent body witnessed multiple water-related incidents before its fragments coalesced into Bennu. Other scientists studying the extraterrestrial samples found abundant water-altered compounds called phyllosilicates, as well as a rich collection of other organic and hydrated minerals. Phyllosilicates are structurally bound to water in meteorites, and they may have been the cradles for organics and water that scientists suspect were delivered to Earth early in its history. In a series of talks at the LPSC, the mission team reported that the stones cataloged so far also contained a variety of textures, hydrated minerals, and evidence of space weathering, as is expected from an airless rock that is eons old. "It's a beautiful sample," said Sarah Russell, a planetary scientist at the Natural History Museum in London, who analyzed a small fragment of the sample. "Also, I would say it's not quite like any meteorite in our collection." Another team member, Tim McCoy, a curator of meteorites at the Smithsonian's National Museum of Natural History in Washington, D.C., said, "Unlike most meteorites, whose surfaces are altered by years-long exposure to Earth's air, by the time they are found, pieces of Bennu are the most pristine space rock scientists have ever held. I cannot tell you how refreshing it is to see some samples where everything isn't altered to sulfates and all kinds of muck. You're seeing it literally the day it fell. It is remarkable to see something that fresh." Many of the cataloged rocks from Bennu are hummocky boulders with rough, sandpaper-like texture, said team member Andrew Ryan, a research scientist at LPL at the University of Arizona. Most measured minerals confirm multiple predictions made from remote sensing data collected from OSIRIS-REx as it approached Bennu. "We got it right with the remote sensing," said Harold Connolly, a geologist at Rowan University in New Jersey. "And that feeds directly into how we are analyzing the sample and testing our hypotheses. So far, the analysis has been consistent with the leading theory that Bennu broke off from a much larger asteroid about 2 billion to 700 million years ago. For instance, the latest analysis shows Bennu's rocks littered with impact-related breccias, which are rock fragments loosely held together like pebbles in concrete. These breccias probably didn't form on Bennu, said Tim McCoy, who is leading the research on these features. They formed on the parent asteroid, and then in of themselves became boulders that were incorporated into Bennu. It is still unclear precisely when they formed. We're still in the very early days of this very meticulous work, McCoy said. There's a lot we don't know. All of these findings were made possible by the 5 instruments aboard the spacecraft, whose purposes were to map and analyze the asteroid to the finest detail. The first is OSIRIS-REx Visible, an infrared spectrometer, OVIRS. Its job is to hunt for organics and other minerals by measuring visible and near-infrared light. Then, you have the OSIRIS-REx Thermal Emission Spectrometer, OTS. Using the thermal infrared, OTS took Bennu's temperature and mapped mineral and chemical abundances. This spectrometer works with the first to map Bennu over a range of wavelengths to select the best site for collecting samples. The third instrument is the OSIRIS-REx Camera Suite, OCAMS. This is a 3-camera suite to map Bennu. Polycam, the largest, acquired the first images of Bennu, taking them from 1.2 million miles out, and captured high-resolution images of the sample site. The second camera, MapCam, hunted for satellites and dust plumes around the asteroid, mapped it in color, and took photographs to create topographic maps. The third camera, SAMCAM, documented the collection and capture of the sample. The fourth instrument is the OSIRIS-REx Laser Altimeter, OLA. OLA's job is to scan the entire surface of Bennu and send back data to create highly accurate 3D models of the asteroid surface. According to scientists, one of the 2 Canadian-built lasers failed during the primary mission, but it kept working beyond its expected lifetime and collected all the information required for OSIRIS-REx to land. The last instrument is the Regolith-SRAE Imaging Spectrometer, REXIS. This spectrometer was used to study SRAE emissions from Bennu and help with the creation of a map showing the abundance of different elements on the surface. Unlike other imaging instruments, REXIS examined the composition of the asteroid at the level of individual atomic elements. The OSIRIS-REx mission does not end with Bennu. According to NASA, OSIRIS-REx is expected to make contact with Apophis in 2029. Apophis is another potentially hazardous asteroid that was recently removed from the Century Impact Risk Table. This table keeps track of asteroids where an Earth impact cannot be ruled out. According to NASA, Apophis has been deemed to not be a problem for at least the next 100 years, based on improved simulations of its movements through space. On Friday, April 13th, 2029, Earth will have a close encounter with the asteroid that will see the asteroid come just 19,000 miles from the planet. This is closer than most geostationary satellites. Previously, scientists had calculated that Apophis had a very small chance of hitting Earth during a flyby in 2068, but the reassessment of its risk in 2021 showed there is no threat whatsoever to worry about. But with the asteroid coming so close, NASA decided to use the opportunity to have a healthy and untasked spacecraft available to swing by. NASA announced in April 2022 that it would redirect OSIRIS-REx to make the most of the encounter and rename the spacecraft after it drops off Bennu samples at Earth. In 2023, the spacecraft's name was changed to OSIRIS-APEX, and it is expected to reach Apophis in 2029. Aside from one of the transmitters of OLA, the instruments on the spacecraft are all healthy and functioning correctly. This will allow the new OSIRIS-APEX mission to do its job. The spacecraft is expected to examine Apophis for 18 months and get close enough to examine the asteroid in great detail. It is important to note that OSIRIS-REx is not the first asteroid mission to return samples. While it is the first to return samples to the United States, Japan has already shot ahead with 2 similar missions. In 2010, Hayabusa became the first spacecraft to bring a bit of an asteroid back to Earth. A successor Japanese sample return mission, called Hayabusa 2, did the same with asteroid Ryugu in 2020. NASA's Dawn mission, as another example, visited the asteroid Vesta before moving on to the dwarf planet Ceres. However, this is in contrast to the OSIRIS-REx mission, as the Dawn mission did not return samples. Its visit was for other purposes. Beyond its work on Bennu, it is expected that OSIRIS-REx will also help astronomers study the Yarkovsky effect on asteroids. This phenomenon occurs when heat from the sun provides a tiny push that alters the movement of an asteroid or other object. Although the push is minimal, it can build up over time, helping to change the path that a space rock travels. So while research and analysis are ongoing to determine what Bennu really looks like and what it contains, scientists are seeking to ease any worries about the possibility of close contact or even a collision with Earth. This means we should be excited rather than anxious.